cache manager into Caffeine Cache Access Helper. Just for you, when you have some time, since it's better to move these two configurations. It was in the early days we were in Rush, so I put it here. But now it's better to move this with the same name, this name of caches to config file. Okay, so basically we have a constructor, and basically what we're doing is we are getting the native cache for initialization. That's it. For other methods, we are using this to generate the key. As you may know, for a long time we were using Elasticsearch query string as the string, regardless of the start date and end date. Now, for last few releases, what we are doing is we are creating basically the cache key based on the input parameters. So this method is overloaded but it's only a string concatenation. But see, what I would suggest is do not use plus sign when concatenating strings. It's hampering the performance of the whole application. Okay, so the next method is get cache key for the data, which basically same thing. It's pretty obvious. And the reason that I am still keeping these two as a reserve word at the end of the date is, see, as you can see, I'm removing them in the code, but I'm still keeping them as a reserve word that we may use something. We may need them to expand our query, and this is how we can separate between old key and whatever we are adding to. Okay. So basically, there are two other methods. First one, convert meets to time series and convert time series to meets. And as you may know, mid object is the basic data structure for this project, and time series is basically this one, basically array of primitive data types for tenors, and the reason is to reduce the our memory footprint. We have moved from in the cache we are only using primitive types. So obviously we need two methods to convert meets to time series and vice versa. Just to compensate for inflating and deflating objects, frequently I'm using a fork chain framework to be able to parallelly process all the to process the input stream, which might be a list of meets or a list of time series. They are similar, so this is, and I have added many different commands in the code that just to help myself for future references, but it's really helpful for next developers to follow. So yeah, this is basically these are two methods. And for caching, it's really simple. It's, as the name implies, we are checking the cache based on the input parameters and converting to ISO standard format. And we are checking the if input date and start date and that they are complying with our caching policy. Complying with our caching policy, we are caching it. Otherwise, we are just logging in and say, hey, cache is not updated because the start date and end date is not in our caching policy. So that's for this one. This one filter by date range. Basically, as you may know, users are not allowed to cache. So I believe you both are aware of how Recast's cache warmer is working, right?
Yes.
Hello. Okay. So we are augmenting the we are not we are augmenting the start date and end date for now from 2019 to 2099. So definitely what users are looking for is not that humongous range. So then we are filtering the time series based on input and output. This for loop should be improved into for now, and I would suggest to use filters and Java Stream API. And then once the data is created, as you remember, time series is in the array of dates, as an array of integer, price as double, and tenors as a string. So yep. So once we extracted all the data, converting list back to primitive data type. Basically creating a new time series and turning the object. The simple getter and setter method. Okay, and this one is similar request already cached, and how we are checking the request. We are checking based on the first of all, we are getting the cache name and cache key. So we're using cache name. Since we have three caches, one cache is automatically handled by as managed by Spring Boot, and two other caches that we are directly controlling two caches for DSS and indexes. So we are getting the cache name and using the cache key. Basically, and a very simple filter. We are using we're getting the cache. If we find something in the cache that we return, otherwise we return an empty collection. So this is for Cafe Nexus Alpha. Next class is Index API Service. That's, as you can see, this is the task that we are working to pull out everything from these two start and end date from configured properties and moving to OpenShift sequence. So, but for now, we are injecting the values once bin is created in the container. So, okay, and what we are doing is using Cafe Nexus helper. We are getting the cache and checking if if the object is available in the cache, okay, so return and this flag. It is data in cache. So, and I have comments everywhere to say why I have set the flag to true or false. So you can follow along with me easily just when exploring the code. So if something is in the cache, so we are returning and just we are raising this flag as true. Otherwise, we are checking to see, okay, if exact same thing is not available as similar request is already cached. Which this one, this type of caching, we call it time range caching because we are searching in the range. So, okay, if we find something, now we are returning the whole object. Otherwise, we are hitting the Elasticsearch. See, and this one, see, we hit the Elasticsearch to get the values. So this one is going to be false, and we are returning. If since we are here, so we were not able to find something. Obviously, we will return false, and it doesn't matter whether it was in the cache or it was not in the cache. We are just returning an empty collection. Next, this one we are using this for, I guess, we are using this method for create_dshist, and this one for indexist. For the input, we are getting the Elasticsearch query, cache key. For just Kerf key, we are using Kerf key only for logging purposes, and we focus on cache key and ES query. And that's this was pretty much similar to the above one. When we are checking the cache, if it is available, we are returning the object and raising the flag as true. Was false. We fetch values directly, so false. Otherwise, vice versa. So, and this one here is time range caching, pretty much similar to the previous one, raising the flag, and you can see the comments here. So you cannot go wrong with this comments. Even if you decided to change the logic, you can always refer to the comments and change the logic accordingly. And this one, at this step, definitely we have hit the Elasticsearch. We are logging in that, okay, we are getting data from Elasticsearch and how long the duration of the process. Okay. Senior, I would suggest to refactor these two method and make and extract two functions. Code improvement was one of my tasks, but didn't never get a chance to get it done. And this one is for caching MIP index. As I mentioned, this method is completely controlled by Spring Boot, and since there are very small, we are working with very few amounts of MIP objects, so we have not converted. We decided not to convert it to time range caching, or leave it to, and just why I decided to leave it to Spring Boot to manage this part. So this one is coming from caching version 1, and the remaining on is caching version 4. this is basically how we are leveraging cache in this and how we are using it actually. Right. So this function comes after controller, and once we're calling this primary data, this is the method that they were using. I mean, Shanghai 2. From this point, they were getting the Elasticsearch, but we have changed, we have modified the logic. So, if you remember, we have a flag, so, and we are working, and each of, and the method in caffeine access helper are returning a pair. So, basically, second element or the right element is this flag. So if something is in the cache, just filter it. And whatever you got, convert it and return the mids. And you don't need, and don't bother to just return the values. That's it. Otherwise, go and hit the Elasticsearch and so on and so forth. So this is how we are using it. They're pretty much similar things. Basically, creating cache key, calling this method and then index API service. If something is available in the cache, get the object. Otherwise, just use time range caching. If failed, hit the Elasticsearch. That's it. For concurrent programming, I would suggest to maybe, if you're familiar with fork join framework, even better. Otherwise, I encourage you to take a look at and at least make yourself familiar with parallel streams and how they are different when we are saying stream.parallel or parallel stream. So, otherwise, code is a really, I've tried my best to basically make it readable. Some more refactoring is needed, and I have tried to make exact copy and paste to make refactoring or introducing new methods with a simple click. So, and you can find very similar lines of code, so it's going to be very easy for you to refactor the code and reduce the lines of code. And yep, that's pretty much it for caching.